Hi, it's me again, your friendly neighborhood math teacher. Today we're going to be looking at 3.3 forms of a line. Linear functions come in a variety of forms. The two shown below have been introduced in Common Core Algebra 1 and in Common Core Geometry. The one on the left, the slope-intercept, is probably the one we're most comfortable with, y equals mx plus b, where m is the slope and x comma y represents a point on that line, and the point slope on the right hand side is another method. You may have learned this in Algebra 1 or in Geometry, and you might not have. So we're going to look at both of them today just to make sure we understand how to use both and how to manipulate both to get to the other one. So in exercise 1, we consider the linear function f of x equals 3x plus 5. Determine the y-intercept of this function by evaluating f of 0. Well, easy enough, we can do f of 0 is equal to 3 times 0 plus 5. So f of 0 is equal to 5. I'm going to just remind you that represents the point 0, 5. All right, so find its average rate of change over the interval between -2 and +3. So if we consider, what we need to do is find the slope, right? Average rate of change is the slope. So what we're going to do is we're going to do f of -2. And f of -2 is 3 times -2 plus 5, which is -6 plus 5, which is -1. So again, I always just try to keep in mind it represents the point -2, -1. And then we do f of 3. f of 3 turns out to be 3 times 3 plus 5, which is 9 plus 5, which is 14. So again, this is the point 3, 14. So in order to find the average rate of change, which we just did in our last lesson, we have to calculate the change in f over the change in x, which is the same thing as the change in y over change in x, which is 14 minus a -1 over 3 minus a -2, which is 15 over 5, which is 3. Looks like a 0.3. It's not. It's just 3. So that's done. Pause, write down what you need to, and then we'll move on to exercise 2. Consider the line whose slope is 5 and which passes through the point -2, 8. So write the equation of this line in point slope form, namely y minus y1 equals m times, or the slope times, x minus x1. So again, we know in this case the slope is 5, and the point that's on the line is -2, 8. So in point slope form, it's going to be y minus 8 equals m, which is 5, over x minus a -2. And again, we're going to just simplify this. So it's y minus 8 equals 5x plus 2. B says, write the equation of the line in slope-intercept form, y equals mx plus b. Now, we can just take this right here, and we can rearrange this. So if we distribute the 5, we get y minus 8 equals 5x plus 10. Add 8 to both sides, making sure to combine like terms. So y is equal to 5x plus 18. So we know that the y-intercept is 18 in this situation. Now, could you have done it a different way? Absolutely. Right from the beginning, you could have said, well, I know the form of a line is y equals mx plus b. I know that y is equal to 5x plus b. And I know the point that's on this line is -2, 8. So we can substitute in our x and our y to get 8 is equal to 5 times -2 plus b, 8 is equal to negative 10 plus b. Add 10 to both sides and we get 18, which is still going to, then y equals, make sure you answer the question, 5x plus 18. So it doesn't matter which format you use, you can get down to the same answer. Exercise 3. Which of the following represents an equation for the line that is parallel to y equals 3 halves x minus 7 and which passes through the point 6, negative 8? So, give it a couple of minutes. Think about what characteristics parallel lines have. Well, hopefully you're remembering that if two lines are parallel, if you think about things like this, then they have to have the same slope. So if we're talking about an equation that is parallel to 3 halves x minus 7, remember, if you think about putting a graph in the middle of this, they're going to have different y-intercepts, but the slope's going to be the same. So thinking about this, we know that the same slope, and we could do point slope form because that's what our answers are all in that form. So this is easy enough. So it's going to be y plus 8, y minus a negative 8 is y plus 8 equals same slope, 3 halves x minus 6. So our correct answer would be number 3. Now remember, I changed this to a plus because I did the double negative. Y minus a negative 8 turns into a y plus 8. Moving on to exercise 4. A line passes through the points 5, negative 2, and 24. Determine the slope of the line in simplest radical form. Well, hopefully you remember from last year, from last week, from yesterday, that the change in the y, or the change in the f, over the change in the x is going to be 4 minus a negative 2 over 20 minus 5, which is going to be 6 over 15, which reduces to 2 over 5. B, write the equation of this line in point slope form. It doesn't matter what point we use. So if I use, let's say, this point here, I can say y minus a negative 2 is y plus 2 is equal to my slope, which we just figured out, times my x minus 5. Or you could have had, if you wanted to use the other point simply would have been y minus 4 equals 2 over 5 x minus 20. Both yield the same line. C, write an equation for this line in slope-intercept form. So again, we can do it either way. Because we already have it written in point slope form, I'm going to just rearrange this as y plus 2 is equal to 2 over 5 x minus 5. Don't be concerned about the fractions. It's not a big deal. I know it's the F word of mathematics, but we can get over it. We are Algebra 2 students, professional students. 2 over 5x minus 2 over 5 times negative 5 is negative 2. So, minus 2 from both sides. Y equals 2 over 5x minus 4. There you go. And D, for what x value will this line pass through the y value of 12? So again, I like to visualize things. The y value is 12, it wants the x. So what we're going to do is we're going to use one of our equations. Does not even matter which one we use. Well, why don't we use this one right here because it happens to be convenient to us. So y, I'm going to just write it down first and substitute in our x. So y is equal to 2 over 5 times our x minus 4. So, wow, what are we doing here? Oh, put this whole thing in your calculator, and you get the wrong answer because I'm substituting in the wrong one. All right, those of you who are screaming at the screen saying, Miss Teach, you're doing it wrong, we have to substitute in. This is the x, this is the y. So it's 12 equals 2 over 5x minus 4. Okay, this is looking better to me now. Adding 4 to both sides. So 2 over 5x is equal to 16. And then we multiply both sides by 5 over 2. Multiply by the multiplicative inverse. And x turns out to be, drum roll please, 40. All right? So we know that our x up here, instead of being x, this is going to be 40. So pause, write down whatever you need to, and we will come back in a couple of minutes. Okay, exercise 5. Our last exercise. Again, remember, we keep looking at equations, tables, and graphs. So here's a graph situation for our lesson today. The graph of a linear function is shown below. Write the equation of this line y equals mx plus b form. Well, easily enough, we know we need m and we need b. So looking at this, we know our m is going to be up to right one. It's a positive slope because it's heading upwards as we move from left to right. So I know my m is positive 2. I know my b is where it crosses the y-axis at positive 1. So easily enough, y equals 2x plus 1. What must the slope of the line perpendicular to the one shown? What must be the slope? So they're not asking for the whole question, just the slope. So I'm hoping you remember what the slope of a line perpendicular is the negative reciprocal. Do you remember that? So if we have 2 over 1, create a fraction, even if there isn't one there, 2 over 1, and the negative reciprocal means you change the sign. In this case, it's going to be negative 1 over 2. Draw a line perpendicular to the one shown that passes through the point 1, 3. So through this point, using the slope of down 1, right 2, down 1, right 2, you can follow it up. Because I do not have a nice ruler on this, so I'm going to have to freehand it the best that I can. And ask yourself, make sure you check it. Does that look like it's perpendicular? Sure does. And write the equation of the line you just drew in point slope form. Well, we know the slope was negative 1/2. We know the point was 1, 3. So in point slope form, you get y minus 3 is equal to negative 1/2 x minus 1. And E, does the line that you drew contain the point 30, negative 15? So we're simply going to plug this into the equation that we have to the left. So our x and our y, lately I seem to be getting those mixed up, so I better write that in. So 15 minus 3 equals negative 1/2 of 30 minus 1. So we want to know if, I'm sorry, it's negative 15. So negative 18 is equal to negative 1/2 of 29. And the answer in this case is no, because it's negative 14.5. All right, so make sure you're answering the question. Does the line that you drew contain the point? We're going to say no. And justification, we just showed it. So we're going to say no, the point, 30, negative 15, does not lie on this line. You don't need a because here because your justification is mathematical, and it's right here. So that's pretty much it. We've looked at 2 different types of forms for a linear equation, and depending on what they're asking you and what the context of the problem is, you would be able to choose either one of those, because I think either one of them are equally easy to work with, and it's easy to manipulate one into the other quickly. So we are done with lesson 3.3, forms of a line. And now tomorrow we'll be discussing it. Please bring your questions with you, and I'll see you next time. Ciao for now.